Hey, so what are you going to show us today, John? What are we going to look at?
Yeah, thanks, Chad. So we're going to be looking at the Pectra upgrade, which is the latest Ethereum hard fork that happened on May 7th. And we're going to be looking at it through a data lens.
Mhm.
And I'm the head of research for Agnostic, which is a product company, and we deliver blockchain data through a product which we have two aspects of it. The AGX, which is a native SQL engine, which kind of can be used for any big data set, but we have been specialized and focused on blockchain data and specifically around Ethereum and the EVM compatible chains. So we're going to be looking at Ethereum's upgrade because it was really impactful in terms of the performance that it added to the chain and the changes that were made there. So that change happened on May 7th. So it's really timely that we're talking about it now, because so we could actually like look at how it performed. And with our organization is called Agnostic. We like to say everything that we're doing is, we back it up with data. So let's look at this from a very unbiased perspective with that lens.
Cool. So all the nodes are upgraded now, and we're going to look at what the impact of that upgrade was on the flow of data through the system. Yeah.
That's exactly right. Yep. Yep.
Cool. All right. Shall we look at some code?
Yeah, if we could bring in the screen, that'll be good. And so yeah, what we're going to be looking at here is, like I mentioned, there's kind of two parts to the Agnostic platform. AGX, which is like a native SQL engine, um, and this brings in our blockchain data sets that we have available. And so, we can look at things like logs and transactions. This is either looking at like base data or Ethereum. Um, and this is actually also a native app. So you could download it and then, drop in, I could flash that quickly, but, this is the native app AGX, but you can drop in any data set that you might have here as well. Um, and so this is kind of cool. And it looks at any Parquet data set. Um, but what we're going to be looking at is DGen, which is kind of like a notebook experience for data scientists or anyone who really wants to kind of like publish their thoughts about a data set. And so we've done that around Pectra and the Ethereum upgrade. And so we'll be looking at this notebook through this talk. And then if the conversation goes in any other direction, we can also bring up other notebooks that we've built. And let me hide this thing, because that's kind of annoying.
Cool.
But
So
yeah, we could look at
it's actually
other.
publicly available. This DGen thing. Anyone can go look at this notebook right now, right?
That's right. Yeah. So there's a couple different options. Like you can make it kind of similar to like YouTube, where you could have it private if it's something that you just want to like look at yourself. You can make it unlisted, so you can share it with others that you want to share with, but not publicly. Or this is a public notebook
Cool.
intentionally. Yep. Um, so this is one that we've kind of communicated out as well, through our social media and whatnot. So you can see the number of views that it's had, and hopefully you can put tags and stuff, all that flavor if you wanted it. But we want to go into the real interesting stuff here, which is Pectra. So we'll just dive right in. So one of the things that now recently Ethereum has kind of put like a goals around. I'm not sure if you saw the protocol announcement that they recently released, but the Ethereum Foundation is kind of centered around a few different goals. One of those being scaling the L1, the other one being scaling L2, and the third being UX improvements. So this is one thing that we want to look at here is doubling the layer 2 scalability by increasing the blob capacity from 3 to 6 blobs per block.
Okay, so this was one of the goals of the Pectra upgrade, that this objective here?
This is a goal of, yeah, like overall, the vision of the chain is to kind of, yeah, optimize for all of these, those three things: layer one scalability, layer two scalability, and UX. But this particular change, doubling the capacity and changing the max to 9, was a one of the changes in Pectra on May 7th. So here we can see this, yeah, with data to support whether it was effective or not. Because yeah, the idea here is that it should, we should see the increase in blobs per block. There should be a fee reduction. The idea is that when you add capacity for data availability, that the costs will go down, and we can see the fees kind of appropriately resetting based on that. I like to think of Ethereum blocks and blobs are one part of the block, but I like to think of them as like a train, and you only have so many seats on a train. But if you add seats, one, the ticket cost should go down, right? And you should get more people, more passengers should be able to get onto that train. So
Right.
that's kind of what we're seeing with this change here, 7691 AFE 7691.
All right, cool.
So here we see. So now, like I was kind of mentioning, all of this has SQL behind it. So like this was ran in AGX, looking at our the data that I was showing earlier. So this is looking at block data and basically looking at the average of blobs that were, and looking at this through the column that we have here is blob version hashes, and we look at the length of that to determine the count of how many blobs were added into a particular block.
Okay.
So
Let me ask you a dumb question real quick,
yeah,
just so I understand the data sets. So like when you were looking at AGX on the left, you have this folder view.
yeah,
The folder view actually has a list of available data sets, and those are ones that are on some big server somewhere that the Agnostic team has parsed out and put into a SQL readable form. Is that right?
that's accurate. Yep. These are just Parquet files that we are kind of hosting here, and making them available publicly, so anyone can query this data set through AGX. Like if I just copy this, now this will probably take a bit, but yeah, if we run this here, maybe we can limit the number of the time here, but it will essentially fire off that query to those tables. Correct.
I see. So you're running it on a smaller data set, and a Parquet
Yeah,
file is a file format for large structured data, right?
that's correct. Yep.
Yeah.
Yep. So, and that's where, we have I'm going to focus on the research side, but the tech team has optimized this in a way that it can be done. Like, we're using things like Apache Iceberg and, certain, um, big data technologies, so that this is actually efficient, so that I can run a query like this in under 18 seconds. That probably looks over, there's probably millions of rows that this just scanned to get to this data that we see on the screen here,
Cool.
which is
So
very good.
AGX is like the workspace, workbench kind of thing, and DGen is the place where you put it all together in a nice documented format and share it.
Exactly. Yep. And this is more general, like this can be used for any data set. We use not only Agnostic's data, but we're pulling in other public data sets as well. So this is like ETH Panda Ops, which is a really, I think it's a ETH Foundation, actually. It's a publicly funded project. and they have like data sets that they publish, and we just pull them in, right? So they're hosting their Parquet files, and we're bringing them in here, and I can also write queries on that. Or Flashbots has things like the mempool, and we can take a look at that information. Paradigm has their data, etc. So this is, it could be anything. It could be location data, geolocation data. We haven't done that yet, but it's flexible enough to kind of take a look at those data sets as well.
Cool. And can you join those together in the same queries, the multiple data sets?
Oh yeah, absolutely. Yep. I mean, you need
Okay.
to be careful. Obviously, those will take longer. And AGX does have a limit. Now, locally, you can run it as long as you want. Like, if I'm running this locally, it can take. Just going to use your own resources. But when we're on the hosted version, there's a minute timeout. So that does have. You want to make sure it's under that minute.
Cool. All right.
But
Sorry
then
for the interruption, but thank you.
no. That's a good question. And I guess one of the differences here between, to continue that kind of, the difference between DGen and AGX is like, this will run every so often. Like, this is asynchronous. So once you save a query into DGen, it will constantly update on a either daily basis or even more frequently than that, depending on how much resource we have available. So this is always updating versus this. I have to keep pressing this button to get updated data.
Right. Cool. But then when you look at DGen, it's already run. So you're looking at a cached version. So it doesn't take 10 minutes to load a page.
Exactly. Yep.
Nice.
Right. So there's other tools that, have this type of structure. A Dune is maybe one of them. Flipside is another. But the difference that we really are, that what we like to, our philosophy is that data should be open, right? So I think the most kind of data sovereignty is an idea where, if you want to have the data on a local desktop, and you don't need to rely on any central party to kind of run this, then AGX and Agnostic's tool set is an amazing tool for you. You could actually run Ethereum, all of this on a local desktop with no problem at all.
Okay. So all of this stuff is open source, including the data sets that you generate?
100%. Yep.
Oh,
Yep.
okay. Great.
Cool. Yeah. So yeah, we want to be a public good. We want people to really know, have the ability to, own every part of their flow, which is a great feature of both Ethereum data, blockchain data in general, right? The idea is transparency, to make sure that everything is open and out there, and to enable trust in what you're looking at. And to do that, and it's best to have ownership in that. And so, now we don't want things hidden behind black boxes, and sometimes that does happen. And we want to open up that black box. And Agnostic's tools are a great way to do that.
Cool.
So yeah, we can go more into right, like what is the power of this type of system? And yeah, it's kind of like looking at things like this change of Pectra, and was it actually valuable for the ecosystem? And blobs right here is a great way to kind of start and look at this. So the right here, the target for blobs before May 7th, which was the release of, or the hard fork of Pectra, was exactly at 3, meaning we were hitting the upper limits of, actually before like November, it was below 3. And there's some moving averages that you could add to this chart as well. Oops, I kind of lost that, but if we want to look at moving average instead of the actual average itself. But we started hitting that upper limit around November of last year. And the idea here is like, it needed more capacity. There needed to be more seats added to the train. And so that did happen with Pectra, and now the target now is 6. The limit is 9, but we're not at that limit at this point. So we're actually at like 4, around 4 right now, floor blobs per block, which is good. I mean, there's still upwards capacity. And what did that do in terms of the fee market? Here we can see there's 2 parts of a blob fee, and it's either the submission cost or the main net cost, and that's like the block itself will have a fee associated with it. It will have gas associated with it, but the blob cost itself, how much it was actually submitting to, or how much it cost to submit, is the portion that basically went to 0 after Pectra. So here, these are the yellow portion here is submission cost, and this is basically the main net cost is blue. We've eliminated that through the Pectra upgrade. So all of these blobs, and we can see that a little closer with the fee price here. It's effectively 0 right now, and it has been for the past few weeks.
So a stupid question about blocks now, or blobs. Sorry.
Yeah.
So blobs were only introduced within the last couple of years, I think, right? The Dankun upgrade, and they themselves are, as I understand, an optimization mechanism to. I'm not sure if it's for throughput, but definitely for cost, for data from L2s, right?
That's right.
Is it right to say that, like, back in November, what we're really looking at is either there was low throughput from L2s, which I'm assuming is not the case, because like base, et cetera, existed and a lot of stuff was happening there. So it's probably that L2s had not yet adopted this fully, and we can see the adoption curve and maybe increased traffic hitting the limit of 3. And so if you were, one of the Ethereum core people, then you'd probably look at a chart like this and say, okay, we've hit the limit. We could now further optimize because we're sitting at that limit all the time. Right. So now the limit in Pectra has been increased to 9, and this data would show us we don't yet need to increase that limit, if that's even ever the case. But at least you see there's like headroom, right, for blob usage, which means the L2s are operating more efficiently.
Yeah, exactly. And actually, when you hit that limit, and I think November is right around here, right? And this is actually a great way to view it. Sorry, this has a longer time frame than this one, but anyway, November of last year is right here. Then you start to have a auction. You start to auction off that space, right? Once you hit this limit, and that's what the submission fee is. Now you need to bid for submission into, right? So it's not, base was the one that was paying the most because they wanted to get their blobs in. I mean, you will probably get them in, similar to the gas fee market. Like you might just have to wait, and maybe your finality is impacted based on that. But if you want to pay for submission right away, you can.
Right. And by finality, what you're saying is like you could be doing stuff on the L2 and the L2 considers it done. The user considers the transaction done. But at a certain point, you have to actually commit that stuff to the L1. That's finality. And it could be delayed. And if it were really congested, could be delayed a very long time. Like, back when the Yuga launch of Other Side or whatever it was, like totally clogged up Ethereum. That was before all this stuff, but I can imagine an event like that happening and slowing things down for L2s that aren't paying exorbitant fees.
Yep. Yeah, exactly. And we can start playing around with like the number of transactions and throughput with this now. Like how much more can we do if it's essentially free? To submit these things, could you have bigger blobs, and can you do, larger things to kind of have more? You've expanded the pipe, so you could put more transactions through. So yes, it kind of changes the game now that it's basically free to submit blobs at this point.
Yeah, it's interesting to see like the lack of yellow there, which is the submission fee,
Right.
totally correlating with the number of blobs that go through and the fact that it doesn't hit the ceiling. I guess whenever it hits the ceiling, that's when you're going to start seeing submission fees, right?
Exactly. Yep. So we might see that again, but then to your point, like we will have to do more analysis around because this is all each individual validator, and it's a proof of stake network. Each validator is the one kind of hosting this data set. And will they be willing to, when you add more blobs, which a blob is, I guess I should have explained that, but a blob is a JSON blob of just data, right? It's just stuff that you're putting on chain. And if that, if you're adding more to that data set, it might be kilobytes of data, but if over time you're adding a lot to the resources and the kind of bandwidth that the individual staker needs to have in their system, and we don't want to reduce decentralization. So we need to kind of like weigh those options. Like if we go higher and allow for more blobs and bigger blocks, then do we lose stakers? So far, that has not happened. Decentralized, the network is extremely decentralized, but that is a concern that you would have in kind of making any of these changes.
Cool.
Yep. So yeah, the blob fees are now effectively zero, and will probably be for the foreseeable future until we hit that limit.
Great. I interrupted you when you were looking at the SQL. Yeah, so maybe we could look at the SQL for one of these things and unpack it a little bit.
Yeah. Let's see. This is probably a good one to look at, since we were just looking at fees and the fee data here. This is general SQL, which includes CTEs, or common expressions. And this one we're looking at here is the main net fee that we're talking about. And what the beauty of this is, it is open, right? I think some of the times where you get into trouble, and there's been a few cases where people take Dune data as truth, right? They might even like invest on that, and say, oh, well, it's a Dune dashboard and it must be true because it is Dune. The reality is you should scrutinize queries. You should know what they are. You should understand what the source of that data is, and we could do so here, which is great. So this is looking at transactions itself, and looking at the sum of gas used times the base fee plus the priority fee as well. So that's just kind of breaking down EIP 1559, which has the base fee, which gets burned, and the priority fee on top of that. So that would be for, this is where type equals 3. And I'll actually get into types in a little bit, but effectively there's 4 types of transactions in Ethereum. But this is looking at specifically the blob type transaction, so type 3. So that's where that mainnet fee is, right? How much basically gas does it cost to get in there? And then when we look at the submission, there's another column that we could look at, which is the blob gas used and the blob gas price. And this is also has like a timestamp. I'm saying we're greater than this date, and then we're just summing it all up to see what the total fee is for all of those transactions, and grouping by fee type and time effectively.
Cool. So the fees data thing is like it's composed of those two selects inside of it.
Yeah, effectively just the transaction table is all we're really looking at. But yeah, I mean, if you think about how many transactions this is looking at over that time period, that's a lot of transactions, and we're summing that all up, and it probably takes a minute to get to this data, but there's no kind of this will run asynchronously, and so
Right.
they could come back tomorrow and it'll have a new data set.
So your workflow when you were doing this, you were probably in AGX testing it with a smaller date range like you did a minute ago, just so you could see the shape of the data. And then
Exactly.
eventually you move the date range back and that's what you publish.
Exactly. Yep.
Yeah.
Yep. So I could do this for probably, June, and it won't be a problem at all. And that's exactly right, until I'm ready to kind of publish this. So
Yeah. And if anyone's watching this later, it is June 10th, which is why it makes sense.
right. So 10 days shouldn't be too bad.
So when I'm looking at something like this, the first thing I wonder is, how do I learn the schema? And like, where does the schema come from? Is it an agnostic thing, or is it like just a direct port of the transactions and the actual data structures that are coming from the blockchain?
Yeah, we really don't do much in terms of kind of like translation. This is kind of exactly how the data set is presented, through the. It's an interesting question, but like these are fields that are in the block themselves, right? Like transactions are part of the data set of blocks, right? That's what all blockchain is data over time. So we are looking at that exactly as it is. There's even items that I would say you need to unpack yourself, like we're decoding things. Signature is a very important concept for contracts, because again, this is a smart contract platform, EVM. So each contract has like a signature, and we are doing some unpacking there. So like raw logs would be the signature is not present. It's just data. It's just like a drop of data, and we take that and we kind of unpack it and show the signature. So
what's in a signature? Yeah. Is it possible to show one? I
yeah.
tell you we're going to say maybe I can do that.
Yeah. No. Let's take a look at just a regular select star, right? From Agnostic decoded logs. So now I'm just going to do limit 10. And maybe
just to see what it looks like.
Yeah, exactly. Where date equals, and we'll do 25 June 10th. So this should just give us the full. Yeah. So some of this, and this is where you're getting at, like, what is the? Do we do any translation? Actually, sometimes you'll see binary here as well, which, is something we don't unpack because it's faster. The blocks are built with binary in mind because those are faster. It's a faster data set. But anyway, here we see the signature itself for right. And again, these are like logs of events that were emitted onto the chain. We're showing you these signatures. A very common signature is transfer. That's why I wanted to go straight to that. Like a lot of tokens, all you'll see is a transfer event. And then you'll have the arguments that were kind of embedded in that transfer event.
So we're talking about signature in the way that we use the word signature in programming languages, like kind of like function signatures with types. Although in this case, it looks like we're only seeing events. So like in Ethereum EVM calls, you call functions and smart contracts, and then they can optionally emit events. And what we're looking at is the data from those events here, right?
That's exactly right. Yep. Yep. Exactly. Yep. So you might need to unpack something to like address. So like we offer these user-defined functions that ClickHouse has. So EVM, and I always get these confused, but most likely I think this is encode address, because it's kind of like reverse of what you think. Like I don't want to encode this. I actually want to decode what
Okay.
that address field is, but I just know from experience it's the other way around. But now if I run this, the first field here will be a human readable address. Like this is something that I could go to Etherscan and like find what this contract is and what this reinvest signature is doing here, if that makes sense.
Yes. Yeah. That's the address that we're used to seeing as a
Right.
yeah.
Rather than the binary. So I had to convert that, but that's okay. That's, these are optimizations that the chain is doing. And so we're not changing that. And that's why we're using these functions to kind of do that. But and it's you could go back to even like the raw logs themselves don't even have signature there. It's just data. And it's truly in like binary form.
Yeah. So one of the if you weren't using Agnostic or AGX, one of the things that you would have to do with this raw data, apart from just like actually assembling it and making it possible to query it, is stuff like decoding all this binary data to turn it into something useful to you. But,
Exactly.
Yeah. Cool.
Yep.
You mentioned
Yep.
ClickHouse.
Yeah.
What is ClickHouse and how does it relate to this?
So ClickHouse is the engine that this is built on. So, and I'm not a developer, so this is where, I kind of get a little potentially over my understanding, but it is, as I understand it, there's different SQL engines, like MySQL is one of them. And
yeah, so ClickHouse, it's an open source one in the same way that MySQL and Postgres are, right?
Exactly.
Yeah, that makes sense because like if the job here is very specific to blockchain data, and like the team could have decided to build an entire query engine and large data thing, but rather than reinvent the wheel, they took a really capable open source engine and just built on top of it. But you're not really aware when you're using it, nor do you have to be, that it's ClickHouse. You're just installing and using AGX.
Correct. Unless you want to contribute to the project itself, right? And then maybe you might want to. And yeah, like if we go to our GitHub, right, like all of this is open, and you can see when we're actually like using ClickHouse and et cetera. And there we go. It's using SwivelKit and Plot, and ClickHouse is the backend. But yeah, if you wanted to contribute and change that, so to speak, you can.
Cool. All right, I've taken you on many diversions now.
Oh, no. This is good. That's exactly, we want to explain the real contents of what's going on here, because, that's kind of like we see data and presented in a number of ways, and it's abstracted away, like what actually happens to your point, like what are these fields? Where do they come from? Well, it's not like we're doing anything. There's no rocket science involved here. We're just building up from raw stuff to information, which is like, okay, what is actually happening? But you should, I think people, you should appreciate this, and if you really want to have a deep understanding of it, you should go into the inner workings of it, and then that reduces the trust reliance that you might have on a system. So another thing that was introduced in Pectra was set code transactions. And this goes into the UX upgrade. So I mentioned that there were three things that Ethereum wants to focus on: L1 scalability, L2 scalability, and then UX upgrades, or like changing, modifying UX, making it easier to use. One thing that 7702 allows is this idea of like a ephemeral account, basically a transaction that can use enables an AOA, an EOA, which is a externally owned account, to attach temporary bytecode to its transaction. So basically, it grants smart contract powers like batching and alternative signatures and like paymasters without moving assets from into that contract.
And to clarify, an EOA is like your normal wallet, right?
Yeah,
like what I would have in MetaMask or Phantom.
Exactly. Like if I open this one up, like, yeah, that's going to be an EOA. But a contract is, and only EOAs could publish a contract, right? So you could publish a contract, it's out in the open. But in the past, EOAs and smart contracts had very distinct like use cases, like back to what we were just looking at, like signatures and whatnot. That cannot be done by an EOA, right? Like I can't submit I can't even generate a log. Like I could do a transaction which calls a contract, but I can never like publish a token with a transfer or something like that. Like that's not possible. But here with 7702, I could actually inject that code into a EOA for one transaction only.
Interesting.
Yeah. So it is really cool where it's like it basically will allow you to run that, and then it's gone from your authorization after that happens. And there's been a lot of work done on this, like 4337 version of like, that was the first version of let's try to see if we could get smart contracts or smart wallets built. And that was done through this handle ops function. And that allowed people to essentially like send their transactions to a it was a smart wallet, which Gnosis Safe is a classic example of a smart wallet where it's like it can do things on your behalf, and you could bundle all those transactions together with other users and then submit them once. There's a few wallets that really were like sponsors of this version, like Anbuyer wallet is a good example. But it really didn't take off. And here's the number of kind of like transactions that we see for user ops. Like it's not bad, but in the grand scheme of, and I could show, this is the total proportion of transactions. And we're talking about, for on like a weekly basis, something like 9 million transactions, right? And when we look at something like user ops, we're only in the 14,000-ish area. So it's not a ton of people using these, this style of interaction.
And when you say this style, you mean the new style? Is that the user op or the old
this
style?
Is actually the old style,
okay,
which
the
is
4337.
4337, exactly. Yeah.
Which is the, like, that's the account abstraction EIP.
That is account abstraction, exactly.
Yeah.
Yep.
Okay.
Yep.
So that's the one we all know if we're Ethereum nerds, that was introduced a couple of years ago. And yeah, let's do that. So basically what you're saying is probably most people use EOAs and not smart wallets at this point, and therefore there's not a lot of these things in production. And so 7702's hope is to provide this functionality to everyone else who's not using a smart wallet at this point.
Correct. Yeah. And to get to these user operations, this is not easy to see.
Mhm.
Basically, like I had to do jump through some hoops to see how many people were actually interacting with these user ops. With 7702, we actually see another transaction type, which is 4, right? And it didn't exist before Pectra. Right here, there's no such thing as type 4. And now we have transaction type 4, which is these ephemeral set code transactions.
Mhm.
So
And
we can start
the type you're talking about here is the same one we saw earlier, where 3 was a blob and type
That's
4.
exactly right. Yep.
Cool.
Yep. So 100%. Type 0 is like legacy. Type 1 is type 2 is the class 1559. So it's a
Mhm.
base fee and a priority fee. And then 3, sorry,
Blobs.
type 3 is blobs,
Yeah.
exactly. And now 4 is this ephemeral count, exactly. So we can see the progress that these are since May 7th, when this was added. We can see that it's still not certainly like huge adoption of this, but it has started to creep into the user op um, range of usage, and we're actually seeing now. There is some news around this where a lot of these transactions at the end of May were related to like crime, as reported by Wintermute. I guess a lot of people are like hijacking wallets and using
Uh,
this kind of maliciously, which is unfortunate. So some of this volume is a little bit suspicious, I would say, but um, yeah, I think
they were
now we're
sticking
seeing
malware into bytecodes basically and attaching them to wallets. Oh, that's nice.
exactly, yeah. And it's unfortunate, right? Like, I mean, this is the problem with we're playing with things and we're experimenting, and potentially this in this particular case um, was used maliciously. But we're also seeing adoption from, and there's a really good site that we've referenced before, which is like the EIP 7702 watch or something like that. 7702. No, I don't know if I can find it right now, but I could kind of reference it um, after the call. But
Cool.
effectively, it shows the different wallets that are adopting this, because the wallet needs to actually kind of like upgrade to this type of transaction, and
And then the
also
consumers need to upgrade their wallets once the wallet does. So yeah, I was going to ask that. Like, you'll see adoption go up if it actually is a useful feature, but it'll take time for all of the wallets to catch up, I guess.
yeah. I mean, and then like, what is the point of all of this? Like, I think when I think of like a swap, the UX issue with a swap is that I have to approve a token potentially twice. Like, I have to set a spend limit, I have to approve that token, and then I do a third transaction, which is the actual swap of that token. With something like this, a set code transaction, I can do all of that in one. I can say, hey, use this smart contract, um, which there's a few of these, like Uniswap has its own contract, and like MetaMask has its own contract, and they could like build this in a way that says, hey, a swap, I need to do the approval, and I need to do the set spend limit, and I need to do the swap all in one transaction. And then the user could kind of point to that contract and say, yes, use this thing to do what I want it to do. So they only click a button once, effectively. Um,
Cool.
but yeah, this is the adoption, slow, but getting there. So
Nice. This
um,
will be a good one to watch over time then.
for sure. Yep. And we're going to unpack more on this. I know I haven't, those contracts that I mentioned, like which ones are people using? We need to build out more here. like this distinct EOA is using 7702, and then how many user ops, because you could actually take a user op and plug it into 7702. So this is kind of like the hybrid of moving to moving this logic into a set code. But I don't think probably many people are doing that just yet. That would be like Ambire, I would imagine, would be a wallet that wants to do this, to kind of show that they're a team player and this.
Right. They're one of the
type
first
four.
big smart wallets too, right? Empire.
Correct. Yeah. So, but yeah, more to be shown here once we get there. Okay, so let's go into a little bit more about what else we could see with this change of Pectra. What are we on? Well, 45, 46. So we'll get through this notebook, and then we could kind of see where there's anything else to go over. But one other thing that we saw was, this is related to the blob data as well. A lot of L2s were pushing their data through call data rather than blobs. So this EIP 7623, the idea was increase that cost, call data cost, so that rollups are forced to use blobs rather than use call data. Which, again, kind of call data is, when I think of it, it is like what we were just looking at with pushing a data set through a transaction, where it's not really meant for that. It's meant for to put in a small number of information about, like, maybe this is arg0, which is the caller, and this is arg1, which is, or this is the sender, and this is the receiver of this token, or something like that. But individuals are putting in a lot more information into this the call data. So there was a formula behind this that basically suggested how many transactions would be impacted, and we kind of replicated that within true live data, and we could see how many transactions were actually affected by this this change. But I think one of the big things that kind of like shines light on this is how many there's how many offender transactions there were, and the idea here being, like, the more data we were pushing into a particular block, this is really causing fee spikes, and it would cause for storage increases and whatnot for the execution layer. We basically see that flat line. Now the max of extra gas in call data is in the million, which is a lot, but compared to prior to Pectra, some of these transactions, which we can actually look at with live data. So, like, I could show you a particular aggressor transaction back, like, what this might look like. Here's a transaction hash. So if we go to here, I can go to Etherscan and actually, like, show what this is an L2 dumping a ton of data into
so basically this is like taking tons of data and passing it into function calls and transactions.
Exactly.
Where that's a misuse of the functionality, or maybe it was the only way to go for a while until blobs. And what they've done now is introduced a mechanism, as in like game theory mechanism, to disincentivize people from doing this and get them to get their crap together.
Well said. Yes, that's exactly right. And we could see that through data that it's actually effectively working. Like, these people are no longer pushing transactions like this to onto the chain.
Cool.
They have to put those through blobs.
It's fun looking at this, because basically what you've done on this notebook is you've showed like OKRs at the top, and then you're going through and looking at the KPIs and seeing if the project is like contributing to this. As much as I hate OKRs, that is what it is in the best possible sense.
I mean, and that's one of my theories that like Ethereum is growing up, and yeah, we are now the network is becoming more of that. Like we need to now see with data that this is effective. Like the changes that we want to make are effective. Now, like I think some of the researchers are great, right? Like if you look at this, the researchers knew that this would happen, right? Like they kind of forecasted this in a different way. Like we're looking at this live saying, you know, did it happen? They're saying we think it's going to happen, which is said another way. But you know, I give the authors of this a lot of credit, so that you know they're saying, hey, you know, this 4% in the past 7 days would be affected by this. And they know, and it was, you know, according to me, it was, you know, they were right. Like it was around 1 or 2%. You know, these are weekly slices, and that still hasn't changed. There's still a number that are affected, but the large transactions I think are removed, which is a benefit.
Cool.
Um,
So my overarching question now that I would love to answer before we finish is just like
yeah.
how to make one of these notebooks, because we
Oh,
haven't
yeah.
looked at that yet.
Yeah, sure. So let me just go to the home screen too of Degen. I'm not gonna save the changes here. But like these are the public notebooks that are available here. It's a great way to start looking at you know, different you know, like this is a maker one, which kind of just talks about like on-chain supply and like holders and even like vintage analysis and even price. We can look at all of these different things for a given token. But you know, if anyone could go into Degen and create a new notebook, or sorry, what I wanted to go into was like with this maker one, I could fork this notebook and create a new one for just for me, right? So I'm gonna say take this and I'm, you know what, Maker's great, but I actually want to look at Compound or something like that, right? And I could go in and change this to Compound and then start. I have like a boilerplate that I could start to um, take a look at. So now all of this data is being processed. If I refresh, some of it's going to be there, or it might be running still in the background. But you know, this is will queue and it'll be ready when it's done.
Right. This is a bunch of queries that have to run for the one.
Yeah, and right, like some of this didn't wasn't optimized, so it might take a minute to run, but it's, effectively I have a good starting point. Or I could create a blank new one. So new notebook and just start from scratch. And here there's two different things that I could add, whether that's Markdown or SQL. And we might add more items here as well, but for now, these are the two pieces that we think are critical. And yeah, this is just a raw SQL data set. And if I wanted to take something that I got from AGX and just place it into here, I can save it and refresh, and it should give me that same data. Again, after it runs.
Right.
This one should be fast, but
and does it automatically graph it, or do you have to tell it to do that?
that would be the next step. So it'll kind of show it in table form, but then after that, I'll show you that quickly. Hopefully, when that runs. So I could look at my notebooks versus like the public ones, and probably the more. I have a lot of notebooks, obviously.
You probably work on these and keep them private, and then when you're done with them, then you make them public. You can do that.
That's exactly right. Yeah, and then you know anything that we have questions about, like this one's like you know, CryptoPunks, and looking at these like you know, what are the sales of CryptoPunks, and you know, is it changing? Are they going through the auction or whatever? You know, anytime you have a question, you can look at it through a data lens. but this should, there we go. So this was that one that we looked at in AGX. Now, if I wanted to graph something like, now this one's going to be tough to look at because it doesn't actually have anything, but you know, I could build a bar chart and look at maybe like block number or something like that. And then what does that look like? This might not work because it's not actually.
The shape of the data isn't very graphable, but yeah.
Right. Yeah. So that one's not.
So you had bar
perfect.
chart and you had some other types of charts in there too, right?
Yep, we have a line, candle, bar, H bar, and a bubble.
Cool.
So if we look at something that's a little bit more eligible, like what I was looking at with Maker, probably gives you a little bit of a better sense of what that might look like. So, you know, this is a line chart, but I could change it to a bar. That one still doesn't look great because there's just too many items. But yeah, so.
And then given the fact that like there's all these public notebooks, and many of which you've made, so you know what you're doing, it's pretty easy to go just like fork one and hit edit and look and see how to do things and learn.
Yeah, that's exactly the hope, right? Like I think that's why Dune is so successful, is they have so many examples that people are working on. And those are the boilerplates for anyone to get in and play around with this. Now, also there's AI tools to help you, right? So that we have our own tool. So like if you had a question about base data, you can start asking it and it'll help guide you. Or you could use your own model, chat GPT or whatever. But yeah, getting queries created now is pretty simple. Right? I like to think of it. Think it's fairly simple. It's kind of like showing this and you know, making sure you're telling the right story.
Yeah, this is like LLMs would have changed my life in the 90s when I had to do all this nasty SQL.
Right. I know. And the comments too. And that's where you know, nobody likes doing comments, and to say that I've like, is this me doing this? Well, partially, but like it's very well set up where I'm like, oh, I know exactly that, and they're getting better with comments and things like that. So you know, have to give a lot of credit, but you still need a cautious eye with some of these things because like they do make mistakes.
Yeah. I think what I'll do now is I'll go to DGen Space and look at some of the notebooks and then paste some of the complicated queries into an LLM and have it explain it to me.
Yep.
Like it's probably a good way to learn this stuff since you have all these examples that can explain them, I'm sure. Even if it doesn't know exactly the agnostic style of the schema, it'd probably be obvious based on the transaction and block structures.
Yep. And it's ClickHouse, right? And make sure that it, you know, say this is a ClickHouse engine. So there are certain functions that are available to that type of engine versus a MySQL or Postgres or something like that. But yeah, pretty much it does, it figures it out quickly. And if you have something like this is top holders for Maker, if I, you know, wanted to do the same thing and take this, copy it and say, right, do this for compound, you know, actually I could probably just do that by like grabbing the token with this one. But you know, if we wanted to slice this a little differently, LLMs will do a great job with that.
Cool. Great. Well, thanks. This is cool. And
yeah,
you know, normally I would ask like, what can people do? But it's pretty obvious. You can go to dgen.space and play around with this, or agx.app. And then I assume you're okay with everyone spamming you with their questions.
100%. Yeah. The goal is to continue to learn together, and hopefully people have ideas or you know, questions that we can help them out with. And the goal is to learn together.
Great. Well, thank you very much.
Yeah. Thank you, Chad. Appreciate it. Thanks for the time.